So now we're going to look at a case where the model is intrinsically nonlinear, meaning that there is no transformation that's available that can convert this model into what appears to be a linear function. So here we have two independent variables and then we have y. So y is the, okay, here is the same example like what we have dealt with previously, unleaded gas price, okay, that is our y. Okay. And then we have the regular crude oil price. But what we're going to do for independent variables is to take a lag of 1, the unleaded itself, so it's autoregressive term but lagged by 1, and then crude also lagged by 1. So these two will be our two independent variables, which is what is given here as x and z. Okay. And then we will try to fit a model. So let's set up the data Ln unleaded, L1 unleaded, L1 crude. Okay. So let's copy these two. So these two are our x and z variables. Okay, so let's define the variables now. So price of unleaded gas, x sub 1 is L1 unleaded, z sub t is L1 crude. So that's crude, not crude oil. Okay. So now we need to determine alpha, delta, beta, gamma estimates. Okay, we need to find estimates for these, and we cannot use the regular data analysis regression. So we need to estimate this by minimizing RMSE, root mean square error. So that will be like minimizing SSE. So we go back here and set up the fitted unleaded price. So using the as of now unknown values of the estimates. So alpha here, make sure that that is absolute referenced. Okay, model is alpha times the x value. Okay, so here okay, the x value here, the first one is L1 unleaded, okay, plus and this should be raised to the power of delta. So delta is here, and make sure that that is absolute referenced as well. And then you have plus beta. So beta is here, and make sure that that is absolute referenced, times z, okay, to the power of gamma. Okay, absolute reference that. Okay. Now, of course, this is going to be 0 because we don't have values for these parameters yet. But when we run solver will determine those values for those parameters. So now we copy this. Okay, now we have the fitted values and the actual values. Now we can set up an RMSE function, RMSE, okay, the actual y values, okay, comma, the fitted or predicted y values. Okay. So there you go. Now this is what we have to minimize. We want to find values for these parameters, estimates for these parameters, such that this value is minimized. So let's use a different color scheme for this. Okay, so that's what is to be minimized. So go to, we'll use a different color which is different from, so that will be a contrast. So then you go to solver. Okay, so now you say that must be okay. So the objective is to minimize RMSE. So make sure that the max is changed to minimize, and you do that by changing these cells. Okay, and there are no constraints about what these parameter values can be. Okay, there is no restriction that it has to be less than or equal to 1 or greater than or equal to -1 or anything like that. So this is Georgi nonlinear, and now we solve. Okay, and we get an estimate. Okay, now sometimes you may have to run the solver couple of times before you get the real minimum, because this is a nonlinear program. Okay, sometimes solver will stop before it reaches the actual minimum value. So try a couple of times, make sure that you get the same answer. So then you're done. Okay, so that is our estimate. Okay, for this. So our regression estimate equation is going to be, okay, the regression equation is going to be, so y hat is alpha, which is 0.67, right? Okay, times x is L1 unleaded. Okay, and to the power of delta, which is 0.88. So that's going to be to the power. So let's do that, to the power superscript. Okay, and then beta, estimate for beta is 0.04 times L1 crude, and this one to the power raised to the power 0.75. So that will be our prediction equation. So this is your forecasting function. Okay, and we had to use solver to determine the parameter values. So let's change the size. Size is kind of, okay, so that sounds more like it. Now we'll use this function to, okay, so now we have the actual values and the fitted values. Okay, now let's plot these. Okay, from period 2. So let's do a line plot. Okay, that okay, let's plot with month in the x-axis and the actual values on the y-axis. So let's connect it up like that. Okay, and let's add one more function. So that will be the fitted values, and the fitted values start from the second month. So it will go like that, and the x values are now is going to start from month 2 and not from month 1. Okay, so there you go, and it looks like our prediction function is really good. Now let's clean up the formatting a little bit. Okay, so here we'll put the legend at the bottom. Okay, so this is our actual value, okay, unleaded is actual, and model 1 prediction.